Hello everyone, in this video we're going to start to learn the Chap theory. Always keep in mind that the reason we're learning Chap theory is really try to learn how to find outlier in your data set versus just purely understand what's Chap theory. So the Chap theory is coming from a Russian statistician, so therefore the name itself kind of not very familiar to you if you only speak English. So it's literally from a Russian name, they translate it. And so for any population with mean, mu, and the standard deviation equal to sigma, the percentage of observation that lie within k standard deviation of the mean must be at least 100% times 1 minus 1 divided by k squared. Okay. K here representing standard deviation. So basically we want to see, if you think about standard deviation is talking about how wide my data spread out. So basically this theory try to help us understand is if the data is located at how far away from my center, we will consider that is kind of really not normal. Okay, first, we look at if the standard deviation equal to 2, we are expecting 75% of the observation are located within the 2 standard deviation from the mean. Okay, so that's a very decent amount. So basically, we have 75% normal data should be within 2 standard deviation away from the mean. You can thinking about this as a circle, right? You have the center there, the radiation, you draw a radiation, which is the radius equal to 2, you draw that circle, and you are expecting 75% of the data should be within that circle. Okay, if the standard deviation 3, k equal to 3, so here means at least 88.9% will lie within the 3 standard deviation of my center. So basically you extending the radius, draw that circle, and you should be expecting 88.9% data within that circle. And then at least 93% of the data within 4 standard deviation of the mean. Okay, so as you can see, as we extending the radius of that circle, we have more and more data within that circle, right? Okay, so the Chap theory are applied to any kind of distribution regardless the shape. So if it's just data from the sample, and then the Chap rule will be applied. However, most of the data we are dealing with, we consider them follow this called a bell-shaped curve. So if you look at the right down corner here, and then you are able to see this curve, and it's called a bell-shaped because it does look like a bell. And so usually they are normal distribution. Okay, so normal distribution is symmetric and it's also known as a bell-shaped curve. And next chapter, we are going to focus on learning different kind of shape distribution and where we're going to dive in further about normal distribution. But here, I just want to call it out, if our sample size are large enough in the statistical world, we believe the data are going to follow normal distribution. So if that's the case, we can further precise our Chap theory to call it empirical rule. So what empirical rule are stating is that if the data is follow normal distribution, and we believe within 1 standard deviation from the mean, we will have 68.26% of data should within that. And we should have 95.44% of the data within 2 standard deviation from the mean. And we should have 99.73% of data within 3 standard deviation of the mean. So pretty much saying, if our data is belong to our population, we should looking for them within 3 standard deviation. So some students are very smart, as what I'm stating here. You might thinking, hey, so if we feel that all the normal data should be within 3 standard deviation, if we do have a data outside 3 standard deviation, does that mean that data is abnormal? So the answer is you are right. So that is the fundamental guideline here. We're going to talk about later is how can we find outlier? So it's literally based on empirical rule. If we have any observation is outside 3 standard deviation from the mean, and we will consider that data as an outlier. Okay, we're going to look at that later because before we move on that, we need to do one more step because we want to make sure this outlier detection process is very straightforward. In order to make it straightforward, we're going to look at how can we converting our data, any kind of data source, to a standardized format. So this standard format is called z-score. Okay, z-score. So like I said, in our next chapter, we're going to look at the normal distribution again. So there is one normal distribution called a standard normal distribution. So for the standard normal distribution, it's still a part of the normal distribution. The uniqueness of that distribution is that the mean equal to 0 and the standard deviation equal to 1. Okay, so what happened here, when we standardize data, what we did is, given any sample that is follow normal distribution, we are able to do some kind of conversion so that we are converting those data to follow the standard normal distribution. Okay, so what does that mean? That means once we convert the data to z-score, and that z-score is coming from the normal distribution with the mean equal to 0 and the standard deviation equal to 1. Okay, so by doing this, it will help us to detect the outlier very easily. I will show you later. But first of all, let's look at how can we converting any observation to the z-score. Okay, so the formula is listed on this slide. So the z is stands for the z-score, and the xi is your original observation. So basically, using your observation minus the mean divided by the standard deviation, that is how we converting your observation to the standardized data, also called z-score. Okay, so you can do the standardization for your population data, and also you can do it for your sample data. So before we move on to learn how we are able to identify outlier based on the z-score, I want to call out one of the characteristics of the z-score. So if the z-score value is a negative value, that just means your observation is smaller than the mean, or the observation is to the left of the mean. It makes sense, right? If you look at this calculation formula, xi minus mu, so there's no absolute value, so it's just the difference between two values. So if the xi is smaller than mu, which is on the left of the mean, so you will get the negative numerator, right? So denominator standard deviation never can be negative. So therefore, when you have the negative z-score, it just means your observation is smaller than the mean, or your observation is to the left of the mean. And similarly, if you have the positive z-score, it just means your xi larger than the mu, right? So that means your observation is to the right of the mean. And then, so therefore, they give you a positive z-score. How about the z-score equal to 0? So that just means your observation exactly equal to the mean. Okay. Now let's think about it. So how can we find outliers? So first of all, based on the empirical rule, we learned that if the data is the outside 3 standard deviation, that will be considered as outlier. So the problem for that, the inconvenience for that statement is that for every population, you need to identify the mean, identify the standard deviation, identify the mean and standard deviation, and then to apply that rule. So here we try to make it a more straight line by literally converting my original data to the z-score first. So after I convert my data into the z-score, the good thing is, since the z-score is coming from the standard normal distribution with the mean equal to 0, standard deviation equal to 1. So the 3 standard deviation become negative 3 to positive 3, right? So therefore, you are able to, based on the z-score, very easily identify your outlier regardless of what your data are dealing with. So after you convert the data to the z-score, you just need to look at which z-score is larger than 3 or smaller than negative 3. So that corresponding data will be considered as an outlier. Okay, I will repeat one more time. So the rule we will use to apply identify outlier is based on the negative 3 and the positive 3 of your z-score. So if the z-score is larger than 3 or smaller than negative 3, that will be our outlier. Okay, so here we're also calling out something called unusual. So that's less important than the outlier. So if the data is z-score is larger than 2 or smaller than negative 2, we consider as unusual, but it's not outlier yet. So has the 3 threshold you have to remember. Okay, after we know how we are able to standardize the data, identify the outlier, let's work on a practice question together. So the mean monthly rent of the student at Oxnard University is $875 with a standard deviation of 219. John's rent is $1,325. What is the standardized z-score? And is John's rent an outlier? And lastly, how high would the rent have to be to qualify as an outlier? Okay, so literally for this question, we're going to practice on how to standardize the data, finding outlier, and then if that data is not outlier, so what is the actual observation has to be in order to qualify to be as an outlier. Okay, so it's a literally play around the formula we saw, the standardized equation. So after this video, you're going to move on to the computer skill lecture, where we are learning how can we use Excel to quickly getting our z-score, and from there to identify the outlier. Okay, so let me open my whiteboards here. Okay, so let me write down the key getting the key information. Okay, so in this equation, okay, so it's very important we always starting from write down the information we know. So the monthly, the mean is equal to 875, the sigma equal to 129. So my xi in this question is 1,325. So the first question, number A, is asking us to convert it to the z-score, right? Based on the formula, xi equal to x minus mu divided by sigma. So we just apply this formula. 1,325 minus the mean 875, and then divided by 219. So this is how we standardize our value. So let me use my calculator very quickly. Okay, 1,325 minus 875. So the numerator gave me the value of, Okay, so the value give me is 450 divided by 219. Divided by 219. So that gonna give me the value of 2.548. Okay, so this is A. What is the z-score? So the z-score is 2.0548. And the question number B, is John's rent an outlier? Remember, the rule of thumb is based on the z-score. If it's the value larger than 3 or smaller than -3, that will be outlier. Since 2.0548 is not larger than 3, so therefore it's not it is not. So it is not an outlier. Okay, so since this rent is not considered extremely large, still be part of the sample, normal sample. So now the question will be, hey, that's why we have question number C here. How high would the rent have to be to qualify as an outlier? So for this question, a little bit tricky because we still play around this formula, right? Still this formula, z equal to x minus mu divided by sigma. Okay, so as we already know that in order to be considered as an outlier, it has to be at least 3, right? 3 larger than 3 or smaller than -3. So therefore, what I'm going to do is I can calculate 2 outliers. So one is extremely large, one is extremely small, right? But here's how high it would be. So I'm starting from the extremely large one, okay? So the z, so we're going to look for when z need to equal to 3. Remember the threshold is 3, right? So then we just need to figure out what's the value of x has to be so that the z will equal to 3, right? So once we know that, so that will be a cutoff rent price in order to be considered as outlier. So after I do that, so my x, so if both sides times 291, right? 291 times 3 will equal to x minus 875. So on the left hand side, that will give us 219 times 3. So that will give us 657 equal to x minus 875, right? So then the x will equal to both sides plus 875, 657 plus 875. Okay. So that will give us plus 875. So therefore the x will give us 1532. So in order to consider as an outlier, so the rent has to be larger than 1,532. So that's how high would the rent have to be to qualify as an outlier, 1,532. So that's a high end. How about student said, how about low end? So how low would the rent have to be to qualify as outlier? So we can do that too, because we know the lower boundary will be -3, right? And x minus 3 A75 divided by 219, and both sides times 219, so it will be -3 times 129. So the right hand side we left 1x minus A75, and then we will know on the left hand side here gonna be negative 657. Oops, right? Because this is the same calculator but with a negative sign, and equal to x minus A75. And if both sides plus A75, so this 5 will be A75 minus 657 equal to x, right? If both sides plus A75. Okay, so then this is going to give us A75 minus 657, give us 218. So similarly, on the other side, we will have extremely small value if the rent is cheaper than $218. Okay, so that's the answer for the practice question. Hopefully, this practice question allows you to understand first how to calculate standardized z-score, how to find outlier, and also do some kind of inverted calculation. So given the threshold we know, -3 and +3, when what value of the x has to be in order to be considered as an outlier. Okay, so good luck with your homework, and I know there's one homework very similar to this question. Hopefully you can apply this method to help you to solve that problem.